section 2.2, the last part, is finding the polynomial functions given you have zeros. So the first thing that we need to understand here is that to find the polynomial function, right, so to do this right here, we're going to first need to understand this, is that if x equals a is a 0, so if you have a 0, then we now know that x minus a is a factor. Okay, so if you're looking at this, you're like, okay, so what do you mean by that? Well, let's take a look at an example. So let's look at example question A. So find the polynomial function that has the given zeros. So we have these zeros here. What this tells me is that I know that x is equal to 0, I know that x is equal to 3, and I also know that x is equal to negative 5. So what we're going to do with this is we're going to take these zeros, right, x equals all those things, and we're going to convert them into their factors. So if 0 is the factor, then that means that if 0 is the 0, then x is the factor, times. And then if x equals 3 is a 0, then we know that x minus 3, so x minus 3 has to be a factor. And if we know that x equals negative 5, so if we know that negative 5 is a 0, then we know that x plus 5 has to be a factor. So we're going to write down x plus 5. So we know our polynomial function is going to be derived from this right here. So our polynomial function is going to have the factors of x times x minus 3 times x plus 5. Our job is now to multiply this out. I would suggest distributing at the very end. So the first thing I'm going to do is I want to multiply this guy right here. The result is going to be I have an x on the outside times, and now I'm going to FOIL this out. X squared, that's the x times x. So I'm going to do this one by hand here, and then after that I'll probably do the rest of them kind of just mentally, plus 5x. So we have x squared plus 5x. And then we have to multiply the negative 3x and the x, so minus 3x. And then we have to multiply the negative 3 and the 5, which is negative 15. The result being x squared plus 2x minus 15. Now, since there's an x on the outside, I'm going to go ahead and distribute that as well. And our answer is going to be x cubed plus 2x squared minus 15x. So this is the polynomial function, p of x equals x cubed plus 2x squared minus 15x, given that the zeros are going to be these guys right here. All right, let's try a second example, example B. So on example B, very similar, except this time we have two zeros. We have 0 number 1 and we have 0 number 2. So what this tells me is that my function, my polynomial function, will have a factored form of x minus this, so negative 3 plus square root of 5, and then times x, and then the opposite of this guy, x minus 3 minus the square root of 5. Now these are the ones that are going to take a little bit more time, so you're going to have to multiply this thing out. There are two techniques. If you want to use the box method, this is a 3 by 3 box. I'm not going to use the box method. And then if you wanted to, you can distribute. So we're going to do x times x. So x times x is going to equal x squared. So we have x squared, and then x times negative 3. So we have negative 3x. But there's a third term. There's that radical term. So we have to multiply it by the negative 5. So we have negative x root 5. Okay? So if you're questioning that right there, it's just x times negative root 5, so negative x root 5. And now what we're going to do is we're going to multiply the negative 3. So negative 3 times x. This gives me negative 3x. And then negative 3 times negative 3, which is plus 9. So now we have plus 9 right there, followed by negative 3 times the negative radical 5, so plus 3 radical 5. But then we also have to multiply this guy. So now we got to take that root 5 right there, and we got to distribute this guy. So root 5 times x, which is plus x root 5, plus x root 5. And then we have to take this root 5 and multiply it, that's right, to the negative 3, which gives me negative 3 root 5. Oh, I'm running out of space over here. And then finally, the root 5 times the negative root 5. That one you're going to think about. That comes out, that's right, to negative 5, or negative root 25, which simplifies to negative 5. All right, now you got this hot mess. Okay, so I'm going to collect like terms. We're going to go x squared, and then we're going to say this negative 3x and this negative 3x can combine to give us minus 6x. And then this 9 right here, so this guy, and this 5 right here, they're going to combine to give us plus 4. So we have plus 4 right here. And then you'll notice that this thing will cancel with this thing. So those guys are going to cancel each other out. And then this guy here is going to cancel also with this guy here. So those guys cancel out. And all you have left is x squared minus 6x plus 4. And this is our polynomial function. P of x equals x squared minus 6x plus 4. All right, let's try another example. Question C. So I would suggest that you guys are writing this notes. If you haven't been writing your notes, press pause, press rewind, and put it back to the beginning and start writing these guys in your notes. Okay, so if you have negative root 7 and root 7, then you know that our function, our polynomial function, is going to equal x opposite of that. So x plus root 7. So I'm going to put plus root 7 right there. And then the second root is root 7, so it's going to be the opposite of that, x minus root 7. All right, once you get that, you're going to FOIL this guy out. So this guy is going to FOIL out to x squared minus root 7x, or minus x root 7, plus x root 7 minus 7, which equals x squared minus 7, after you simplify the root 7x's canceling out. All right, now question D. This guy's a little wonky. So question D, you have two roots, but it's saying that the degree has to be 4. So let's start out the problem. Let's pretend that the degree doesn't have to be 4, it's just whatever. So we know that our polynomial function is going to be, sorry, I changed it up on you, f of x equals, so if it's 0, that means x minus 0, but we just write x. So x times, and then 3x minus 3. Now, if I multiply this out, I'll get x squared minus 3x. The problem with that is degree 2. This is telling us we need degree 4. It's also telling us that the only zeros we have, the only roots we can have are 0 and 3. Well, there's a lot of different ways we can accomplish this. So we can do it as x to the power of 3 times x minus 3. We could also go x squared times x minus 3 squared. That right there would give us a power of 4. Or you could go x times x minus 3 cubed. Now, of these three options right here, the question is which one would you want to FOIL the most? Would you want to FOIL this one? And if your answer is hell no, then you're right. Then you're going to have to multiply x minus 3 times x minus 3 times x minus 3. That's ridiculous. You can do this one, probably mentally, but why not go with this guy, the one that's much simpler? So by raising it to the power of 3 there and then doing just 1 degree here, this would be a total of 4. So this is the one I'm going to choose to use. Not because it's the right answer, because all of them are the right answer. It's that this guy's the easiest one. These guys take too much time. This guy's ridiculously long. So we're going to go over here, we're going to put a 3 right there, and now if I multiply it out, I end up getting the polynomial x to the 4th minus 3x to the 3rd, and the roots are going to be 0 and 3, the zeros are going to be 0 and 3, and it's going to be of degree 4. That's problem D. Problem E kicks it up a notch. So this one I have 3 roots. So we have 3 roots in the problem, and we have degree 4. Which of the 3 roots do you think you're going to have multiplicity on? That's the important question. This one? Probably not. That's ridiculous. This one? If you can't do this one, then you probably don't want to do this one, which means this guy right here. So this guy right here is the one we're going to have of multiplicity. So I'm going to write x minus 2 squared times x minus 1 plus root 3 times x minus 1 minus root 3. Now, how you FOIL this out is up to you. I'm going to highly suggest that you multiply these guys, and then you multiply these guys, and then you multiply their answers. What do I mean by that? Well, this right here is going to come out to x squared minus 4x plus 4. X squared minus 4x plus 4. Then you have to multiply this thing out. So if I was to do this in my head, I would say we've got x squared. Okay, so that's x times x. Now for the other ones, that's going to be minus 2x, and then for our last one, it's going to be, let's see, what is that? 1 plus, I'll take that back, 1 minus 3, so negative 2 right there. So if you wanted to, you would FOIL that thing out, and then now you got to multiply this guy. Good news is you've already done something like that. You're going to multiply this guy over here, then you're going to multiply this guy over here, then you're going to multiply this guy over here. That's right, this problem is ridiculously long, and we get x to the 4th minus 2x cubed minus 2x squared. And then you have to distribute this guy, bam, bam, bam. And that's going to give us negative 4x squared, 4x cubed, and then plus 8x squared. Notice how I'm writing it. I'm setting it up so that we can just add column-wise, and then negative or positive 8x, so positive 8x. And then our last one is this 4. It's 4 to x squared, so plus 4x squared. And this guy right here, that's going to be negative 8x. Okay, look at that guy cancel out over there. And then finally, negative 8. So we got a negative 8 right there. So our polynomial function, our f of x, is going to equal x to the fourth minus 6x cubed. This right here is going to cancel out to 10 plus 10x squared. This guy canceled out, and minus 8. And that's how you're going to do this. Now, there's a good chance that my answer is wrong, so you guys are going to want to double check this. If there's any mistakes right here, I'll talk to you guys on Thursday about it. Otherwise, take a look at the assignment, get started. You should be okay based on what you see here. Good luck.